Let's go! Chris King! Chris King! Chris King! Chris King! Chris King! Chris King! The weather guy!
Did you know that not all snowflakes are the same? Okay, well, probably you did know that, but when you think of snowflakes, you probably think of this, or maybe this, because, you know, when you were in elementary school, that was exactly what you cut out with paper. But did you know there are different families of snowflakes, and it all depends on how they are created in the clouds? So in this episode of Chris King, the Weather Guy, we're going to look at maybe some snowflakes types you've probably never seen before. So let's go take a look. All right, guys, we are going to take just a really quick presentation here on the types of snowflakes. So some you're going to know, some you're probably not going to know. All the pictures that you see are actually real pictures of snowflakes that are caught up underneath the microscope. They are things of beauty to behold. So let's get after it. Our very first is called dendrites. These are going to be the ones you know the most. So let's go ahead and get into these. These are called stellar dendrites. They're probably some of the most recognizable. These are the ones when you think of snow, you probably think of these. Their name comes from their star shape appearance along with their branches. So dendrite translates to tree-like. So they have a star and they are tree-like. So that's where they get their name, stellar dendrites. They're quite large, probably easy to spot on your sleeve, and these form when the clouds are very cold. So you have to think about these things forming up in the atmosphere, up in the cloud before they fall. And so we're looking at about negative 15 degrees Celsius or 5 degrees Fahrenheit. So along with stellar dendrites, we also get their cousins, which are the fern-like stellar dendrites. So definitely they have a fern shape to them. I don't know. There's something about these I like just because they've got so much symmetry to them. But obviously you can tell why they are considered ferns. And these are the ones typically are some of the biggest snowflakes. Specimens can be up to 5 millimeters in diameter. That's pretty big. So sometimes maybe when you're, looking at the snow and it's falling, you go, man, those are big flakes. Chances are they very well may be fern-like stellar dendrites. That's a mouthful. All right, so those are the ones that you know. Let's talk about some of the ones that you do not know. Columns and needles. So when we're talking about needles, we're talking about...
Nobody calls me chicken needles. Nobody!
So here's what they look like. Literally, they look like needles falling out of the sky. Oh gosh, could you imagine if those really were needles falling out of the sky? So here's what makes these so unique. The cloud temperature is going to be a little bit warmer, whereas the dendrites kind of develop in 5 degrees Fahrenheit. These are in 21 degrees Fahrenheit. They can be quite common, but they're very small and they're kind of easy to miss. And if you notice a couple of them, especially the ones that are the columns, you'll see there's some hollowness to the columns. I'm trying to illustrate it there with my lovely little mouse. So I just think those are pretty cool. When you think of snowflakes, this is probably the absolute last thing that comes to your mind. And I think that's pretty cool. That looks like a cross that they found. So, and these are just kind of scary looking over here. So these are called columns and needles. Now, there's another version of columns, and they're called cap columns. So check this out. This is pretty cool. Check those out. Look like maybe like an empty spool of thread or something like that. And so let's talk about how these are formed. So what ends up happening is that the cloud's a little warmer when these develop, just like the columns and needles at 21 degrees Fahrenheit, right around there. But what happens is as they fall, they enter some colder air, and that's what allows the plates to grow on the ends, giving them that capped look. So they go from, it's still below freezing, but they go from a very cold to a warm to a little bit colder air as they fall, and that's what cap columns are, and that's how they form. So pretty interesting looking. May not have ever seen those. They're not very common. So next time you're checking out snow, see if you can find one of those. All right, the next one is diamond dust crystals. I can account for these because I actually saw these the last time we had a snow. So check these out. Look at that. I mean, we've got some straight up like hexagons, right here. It's really, really, really cool. So here's the reason why they're called diamond dust crystals. You ever like looked at the snow and you see some of them twinkle, they sparkle in the sunlight? Bingo, those are the diamond dust crystals. They are the smallest snow crystals, and many are no larger than the diameter of a human hair. And they are most often seen in bitter cold weather. And think about how cold we've had weather when it has snowed after the fact. So the basic ice crystal shape is that of a hexagonal prism. And then it's got crystal faceting. So one panel on the right shows a group of small laboratory grown crystals that are nearly perfect simple hexagonal prisms. And so if you're checking those out, you can kind of see some of those over here that they've actually grown. So it's pretty cool. So that's homegrown, but the rest of them are real deal grown. So those are diamond dust crystals. So when you see the snow sparkle, that is the type of snowflake that you are looking at. All right. Triangular crystals. Oh, this is really, really, really cool. So check these out. Isn't that kind of cool looking? I mean, when you think of snow, you don't think of this at all. And so this happens when the snow is falling and aerodynamics are taking an effect to produce these unusual snow crystals, okay? They are typically small and shaped like triangles, and sometimes branches sprout out from the corners, as you can see down here in the bottom right example. It's just unusual looking symmetry. So you probably didn't know that sometimes it snows triangles, but those are triangular crystals. 12 branch snowflakes. I bet you could probably figure out what that means. But here's what they look like. Check that out. And so here's usually what happens when some of those 6 branch snow crystals, some of maybe the dendrites, collide in midair. They actually may stick together and grow into this type of snowflake. It's kind of, you would think maybe the collisions are rare, but they're really not. The 12 branchers are usually not too hard to find if you keep an eye out for them. So those are the 12 branch snowflakes. So basically a collision creates those, which I think is kind of cool. And then finally, we're going to get to rime snowflakes and graupels. So these are not necessarily different types of snowflakes, but it's something that kind of happens to them as they fall through the atmosphere. And so snow crystals will grow inside clouds made of water droplets, right? Then often a snow crystal will collide with some water droplets. Maybe one little drop in the atmosphere hasn't quite frozen over yet. And then it latches on to the snowflake and then it forms into ice. And so these droplets are called rime. A snow crystal may have no rime, a few rime droplets, quite a few, or sometimes the crystals are completely covered with it. Blobs of rime are called graupel or soft hail. So sometimes you can kind of maybe see those down here at the bottom, exactly what those look like. So those aren't necessarily different snowflake types, but it's a phenomenon that happens to the snowflakes. So guys, there it is. Those are all the types of snowflakes that you could see. Some that you probably knew existed and probably some maybe you're learning for the first time. Well, there you have it. That's all the information about the types of snowflakes that maybe you didn't know about. So if you want to know a little bit more information about that, check out the link that I've provided in the description of the video. And as always, stick around for the next edition of Chris King, the Weather Guy. See ya.
The world